Now, traveling with a big group like this is really expensive, so we're going to need to visit a bank. Now, as we walk into the bank, we could spend some time in the lobby, we could get some cash, but actually, I want you to think about the people that are working behind the scenes to make all of this possible, the data scientists, the developers. Now, everything that you're about to see, we're about to show you, I want you to remember it applies well beyond banking. So I want you to think about how you could use these things in your own organizations. Okay, let's talk a moment about fraud modeling. Now, the obvious problem with fraud data is that instances of not fraud show up a lot more frequently than instances of fraud. This is what we call the classic class imbalance problem. And actually, to build models that perform in the real world, you need more balanced data. And the best way to create that data is to actually create it ourselves using synthetic data generation. But that's actually only part of the process. Once you have a model, you need to be able to apply business rules and regulatory constraints so that you can make a decision. Now, let's actually see all of this in action. And I can't think of a better person to show it to you than my longtime colleague, collaborator, and friend, Susan Haller, Senior Director of the Analytics Lifecycle. Susan, come on out. Susan, thanks for being here.
Thank you, Jared. To set the stage, why don't we start like any team may if they were tasked with predicting which of their transactions were fraudulent. And we'll do that with an exploratory model in SAS Model Studio.
All right, let's do it.
Let's take a look. So we're in SAS Model Studio. We're using that original transactional data. Now in this data, only 1.2% of my observations are actually fraudulent.
Okay.
So 98% of my data is non-fraud. We're running a typical modeling tournament here, trying different data pre-processing steps, different machine learning algorithms to determine what performs best. And we can see based on our validation KS statistic, we've chosen our forest model, a KS statistic of 0.83. Now that KS statistic helps us determine how well our model is differentiating fraud from non-fraud. And on paper, we seem to be doing a pretty good job. But let's take a look at our event classification matrix. And this is where the problem becomes clear. At that 0.5 cutoff, my model is incorrectly classifying over 96% of my fraudulent cases to be non-fraud. That means less than 4% of my fraud cases, those cases that I truly care about, are correctly classified. And this is a common problem with rare event data. You mentioned earlier, we know that fraud is rare, and we can see that this model is biased towards that majority class because that's what our data is dominated by. And the result, we're missing more fraud, which is frustrating to both the analyst and our customers.
Yeah, so Susan, I think what you're saying is actually kind of on the surface, on paper, the model looks okay, but actually you can't trust the results because of that class imbalance problem we talked about.
Yeah, exactly. And so instead of trying to squeeze a better model out of our data, let's try to improve the data itself, specifically those rare event cases. And this is what SAS Data Maker is built for. It's our synthetic data generation tool that we released last December, available now in the Microsoft Marketplace. At a very high level, Data Maker is learning patterns from that original data, creating new synthetic rows while at the same time preserving the statistical characteristics that we care about. So let's take a look at Data Maker.
Sounds good.
So I'm in the Data Maker product, and I'm going to go ahead and open up the Innovate 2026 project. Here we've gone ahead and trained a SMOTE model, which is suitable for this imbalanced data problem. And we can see that that model has done a pretty good job retaining those statistical characteristics. Here we're looking at that fraud target variable. So we're going to go ahead and generate some new rows. Now, new to SAS Data Maker and especially powerful for fraud is condition-based generation. So now we're not only able to generate more rows, we're able to generate more of the right row. So I'm specifying my target variable to be fraud, and then I'm going to select my level of interest to be 1. And this is going to result in all of my new rows being fraudulent. We've requested 100,000 rows to be created, and we can see that after I hit generate, that table has been created. We've got 100,000 new rows, all based on that fraudulent condition. All that's left, take these new rows, append them with our original table, and create a new augmented table for training.
Okay, awesome. So now we've addressed the imbalance in the data. So I guess the real question is, did we actually change the model performance?
Let's take a look. So we find ourselves back in Model Studio. We're using now that augmented training table that we just created.
Yeah.
Has 100,000 new fraudulent rows, so my model has a stronger signal to learn from. We're going to apply that exact same model, same approach, same process, just different data. And if we take a look again at that forest model, we can see our KS statistic is now 0.86. So we've improved our overall performance up from that 8.83 we saw previously. But we know the true story is in that event classification matrix.
Yeah.
Let's take a look. Back at that 0.5 cutoff. Now you'll see that my model is correctly classifying over 53% of my fraudulent cases,
Yeah.
up from 4%. And this is the key point. We didn't change the modeling approach at all.
Yeah.
We just changed the data.
Okay, so now, because we've addressed this data problem, we've got a model that we can trust. But a fraud score on its own, really, that's just a score. It doesn't tell the bank actually what to do. Like, you've got to be able to combine that alongside of things like policies and regulatory constraints that I mentioned earlier, and things that we've actually learned from past cases, right?
Yep. And in fraud, that context is really going to matter because we know that patterns are going to evolve. We know our policies are going to change. And embedding everything into a decision rule is going to slow down our teams. It's going to increase our risk. And so we need a way to bring together those models, rules, and up-to-date institutional knowledge.
Okay.
And this is where retrieval augmented generation, or RAG, is going to come into play. In VIA, we can create governed document collections, things like updated policies, things like prior reviews.
Yeah.
So LLMs are able to use that enterprise knowledge safely and securely inside of their AI workflow.
Okay.
So here's what that looks like. We're going to begin by first configuring how these documents are embedded and stored. And we're going to do that using popular and supported models as well as vector databases. From here, we're going to start pulling in documents from approved sources, things like those updated policies, things like those use case reviews. On the Collections tab, we're going to start grouping them into logical collections based on their use case. So in this scenario, we're building a fraud policy and case review collection. And this is really important for those downstream applications because now those applications can query relevant text, not everything that's available to them. So each of our document collections is configured with an embedding model, a chunking strategy, and a storage definition. But before we can begin using them, we have to validate these collections. And we're going to do that using a combination of predefined as well as auto-generated test cases, with our ultimate result being that we have identified and flagged our champion collection. So we've identified that collection, we've published it. Now, when that collection is published, our pipeline is going to stay up to date. If any of our documents change, we're going to regenerate that collection. So our decisions are always being grounded in the latest policy and guidance.
Okay, so Susan, now we can bring the fraud model and we can bring this document collection all together using SAS intelligent decisioning, right?
That's right. So I think of intelligent decisioning kind of as that orchestration layer.
Yep.
It's
Okay.
bringing together data, models, rules, and our LLMs. And at the end of that, it's also making sure that every transaction that comes through this workflow is treated consistently.
Okay,
So let's take a look at intelligent decisioning.
let's do it.
So here we start with that forest model that we created in Model Studio. And we can see that both our required inputs as well as our generated outputs are going to be mapped for us. And our fraud score is being represented by a probability. Next, we're going to start applying business rules or hard constraints.
Okay.
And those are things that are going to help us automate a decision to approve, block, or escalate based on policy. So here you can see we're creating an example of a business rule where anything that cost over $5,000, we're going to go ahead and escalate.
Yeah.
Now, oftentimes, we can lean on this automation and we can approve or we can block, but fraud is a little bit different. It often falls into a gray area. And when that happens, we need to look towards an LLM, using RAG, bringing in those documents to help us make an informed decision. So as Brian mentioned earlier today, we're not trying to replace these deterministic systems with non-deterministic ones.
Yeah.
We're just trying to combine them.
Right.
So let's take a look at the node in intelligent decisioning, and you can see that the first thing we're doing is pulling in that document collection. Again, those policies, those use case reviews. And from there, I can go ahead and start creating my user-defined prompt. Now, what you'll notice is that prompt also allows me to embed or include decision variables as well.
Yeah.
So let's take a look at a transaction coming through this workflow. And in this particular scenario, we're going to have a transaction coming through, cost $8,750.
Right.
It's online. We have no card present. Well, we created a business rule. We know that this is about to get escalated because
Right.
it costs too much money. And so we're going to turn to that LLM to help us make that decision. We're going to go through the process, and the LLM is going to turn a very thorough response. The recommendation is going to reference policy. It explains why the transaction was flagged. It shows the details of that transaction that were passed through the variables that we included in the prompt. And we've done all of that with confidence and traceability.
Yeah, all right, so Susan, just to recap a little bit for everybody. So we used Data Maker. We addressed that rare fraud problem. We retrained a model. We got a stronger, better model in Model Studio. And then with intelligent decisioning, we came along and we turned that model into consistent policy-aligned actions, all with human judgment supported by RAG that you showed us.
That's right.
Yeah, so folks, this is how you scale decisions without sacrificing governance and speed. Okay, Susan, thank you so much.
Appreciate it.
Yeah, let's give Susan a round of applause.